So ESP8266, very, very similar to an Arduino in a lot of ways. So the Arduino is basically a little 8-bit processor, 16 megahertz, 2K of RAM. The ESP8266 is 70 megahertz, 64K of RAM, so it's a much faster processor, but natively it doesn't run Arduino code. It's a completely different thing. That was originally for Atmel-based chips. And what they've done is they've managed to actually put the Arduino code to run on the ESP8266 module, which means we can play lights with it. Now, the modules that I've previously done using an Arduino and an Ethernet shield running E1.31, we can get about 240 pixels off of one of those controllers. The cool thing about this is we can run it wirelessly. The ESP8266 has built-in 802.11bg wireless, sorry, not GN. So at the moment, I put there it can control up to 170 pixels. Theoretically, it can do a lot more, but I haven't been able to get it to work. The author of the code says that 400 pixels should be capable at decent frame rates, but for some reason I can only get one universe out of it. On the GitHub site, he's actually put on there that something to do with multicast, but I'm not using multicast, but it still grinds to a halt if you use more than one universe. They're really, really cheap, $2 to $5 depending on which model you go with. The particular one that I've got here is a little bit more expensive, but it's a lot easier to program. The ESP01 is the very basic, cheapest module, about $2.50. You can program them up pretty easily, but you require an external programming thing. You need to have buttons to reset the device, to put it into programming mode and all that sort of stuff. Obviously, and it's 3.3 volt, so if you want to run 5 volt pixels, you've still got to have a 3.3 volt voltage regulator to drop it down to 3.3 volts, otherwise you nuke the module. The one we're playing with today, the ESP-D1, which is also known as Node MCU Mini. It's standard USB connection. It's got an onboard USB to serial converter, and you just hit program and it just loads it up. You don't have to worry about reset buttons and putting it into programming mode, that sort of stuff. It is a bit more expensive, it's bigger, and you've got to roll your own interface with the pixels. For the ESP01 module, there is the ES Pixel Stick board that's apparently available. There's only been one production run of it ever, and they haven't produced any more. You are getting, theoretically, a better module if you use the ES Pixel Stick, but this is just simple, quick, easy, and efficient. So Arduino software is the IDE, so you download that to be able to program up, write the code, all that sort of stuff. So Shelby is the guy who done the ES Pixel Stick code. So I'm stealing his code, but we're running on a slightly different module and without his interface. So the only real thing about it is the extra code required for the ESP8266. Basically, you go in and tell it to use this, download this configuration, and then you actually tell it to go and download the IDE through the menu in the Arduino software. Now, this one actually says 2.2. 2.2 does not work, nor does 2.1. You must use 2.0.0 for these modules, otherwise it will not work. Some key things, selecting the right board within the IDE, I'll show you that in a minute. And also selecting 160 megahertz for the module. It's sort of overclocked at that speed, but it doesn't run pixels very nicely without that. And obviously the right COM. So there's only 2 lines of code that you need to modify to get this up and running, and that's the SSID and the passphrase. So you have a wireless access point. I would recommend a dedicated wireless access point just for your lights. Don't have it on your home network. enter in SSID and password, and that's pretty much it. And then you program up the device. I'll go through that in just a minute. There we go. That's better. So the Arduino IDE, you need a fairly new version of it. I think 1.6.2, I think, was the oldest version you can have. As you can see here, 2 lines of code for this one here, ESP8266 demo. I'll plug this module in so we can actually program it up. Now this one has actually already been programmed. Obviously that's what's been laying on the desk up there running this whole time. So for me, obviously got the right board selected, serial port. COM11. So it runs this CH340 chipset, which is the USB to serial. So if the first time you ever plug one of these in, Windows is going to complain you need a driver for it. If you Google for that, you can find the driver very, very easily, or go to the Node MCU website and it's there. So serial port COM11, and basically all you do is hit program, upload. So it goes off, uploads the code to the device. Takes a little while to compile. Meanwhile, so I've got my wireless access point sitting over there, which is this one. I want to connect to that. So that's finally, it's uploading now. You see the progress bar. And this little box up here will show us the serial window. So this will actually show the progress of it booting, and it actually shows the IP address of the device. Right, so what we can do, we can actually web browse to that IP address now. So this is a web page that's actually running on this device. So I'm wirelessly connected to the access point over there, and then this is wireless to that. So that web page is hosted on this device. Network configuration, you can reset all the settings here. Now what I've found, the settings are stored in EEPROM in the device. For some reason, it seems to favor the EEPROM settings even if you set them in code. So the first time you program it, it then writes that to EEPROM. And if you program it again, even with changing the details in the code, it still uses whatever's in the EEPROM. So it will remember those settings, which is a bit annoying. But for the first device you ever set up, it's fine. It's only the fact that I've reprogrammed this one. So you can set a static IP, that sort of stuff. You can also see other networks. So it will actually access, these things will act as a wireless access point as well as a client. The key things for us, pixel configuration. You can give it a descriptive name, universe, start channel, and as I said at the moment, 170 pixels. If I put 171 in there, I get about 1 frame a second. 170 and it's 30. So I'm not quite sure why that is yet, but we'll work it out. Obviously, the order of your colors, and it does actually, so this only supports the WS2811 and 12B chips, and the GE color effects if you've got that sort of money. The gamma map I haven't played with. The author mentions that it's broken anyway, so don't bother. Network status, obviously it gives you an idea of what sort of wireless reception you've got. There is also E1.31 status, which shows you how many packets it's receiving, that sort of stuff. Obviously it hasn't received anything since we've rebooted it. So basically, once you've done that, you just treat it like a normal E1.31 device. Just send your traffic to it and it spits out pixels. So in these particular ones, that's as simple as it. So 5 volt from your power supply, off the pixels as well, and that is actually incorrect. It is not D2, it is actually the one that it's labeled D4. There's a weird thing on these particular devices. It's labeled as D2, but that doesn't actually route to the GPIO2 on the wireless module. It goes to somewhere else. D4 is actually GPIO2, which is what it's supposed to get to. So that So it's the first 3 pins from the right-hand side there. There are some caveats to this. We're running at 3.3 volts, and the official WS2811/2B means the signalling needs to be 0.7 times the supply voltage, which it is not. It comes down to about 3.5 volts, which is out of spec for the chips. However, on short runs, it seems to work fine. Ideally, you want to add a level shifter like what Alec's done on his devices and that sort of stuff, and a load resistor in the data path. But that just complicates it. I haven't had any issues yet. On short runs, you should be fine. I've run probably up to 2 meters. I'll put there 1, but realistically about 2 meters. But with a wireless device like this, you can have it pretty much right on the start of your pixels, and it doesn't matter. I probably would recommend the resistor after speaking with Alec, but it does work. If you really want to, get the ES Pixel stick, use that, and it'll definitely work. But for me, I haven't had any issues. I'd be interested to see you putting it on coax, see how far you could actually get on coax, whether you'd get any better out of it. Yeah, but on the 3.3 volt. Yeah, so yeah, absolutely. But realistically, we don't have to worry too much about it. Like it's because it's so close. If you're really worried about it, put a null pixel right at the device, and have the next pixel generating a decent signal at 5 volt levels. And that's about it. Blinky lights, wireless, pretty cool. You can probably run, I would hazard a guess, say 5 to 7 modules off of one access point. Much past that, and I think the access points are going to start grinding to a halt. So it might be better to have multiple access points associating, and so have multiple devices associated with different access points. I haven't had enough opportunity to test it to saturate, but I will. I'm going to give them a thrash. I've got a bunch of the ESP01 modules, so we'll give them a thrash and see how much we can stress them with.
So the modules are just available on eBay or?
Yeah, eBay, AliExpress, whatever, about $4.50 for these particular ones. There are also programming interface boards that you can get, which so you can, it just simplifies it. I think it's got the built-in, basically it's this, but with the connection for the ESP01 module. So you can just plug it in, program it, and then take it somewhere else, which is fine. You can still do that, but you still need that 3.3 volt regulator. So by the time you're stuffing around with it, I think it's probably easy to just buy these. You're probably not actually going to run that many of them, and based on the rest of the budget for the Christmas lights, I don't think a couple of dollars over one or the other is going to make much difference in that regard.